This is question 7 from the SACE Stage 2 Physics course companion from sections 2.3 and 2.4, Motion of Charged Particles in Magnetic Fields. Here we have a proton of mass 1.67 times 10 to the power of minus 27 kilograms in a magnetic field of magnitude 630 microtesla, and it moves in a circular path of radius 8.78 meters. First we need to calculate the velocity of the proton. So here we're just using the relationship R equals mv on qb. We need to rearrange this so that v is on its own. So here just multiplying through by qb and dividing by m. And we get v equals r qb all over m. And now it's just a matter of substituting in the values. We're given 8.78 for the radius in the question. Charge of proton is the same as the charge of an electron, just the opposite sign. So 1.6 times 10 to the power of minus 19 coulombs. And the magnetic field is 630 microtesla. Micro is 10 to the minus 6, all divided by the mass of the proton, which we're told is 1.67 times 10 to the power of minus 27. And if we substitute that into our calculator, we get 5.3 times 10 to the power of 5 meters per second. That's it for that question. Part B. Here we're trying to work out the force acting on the proton due to the magnetic field. Since it's moving in a circular path, it must be entering perpendicularly, so we're just using the relationship F equals QVB sine theta, where theta will be 90. That's just a matter of substituting in the values again. So again, Q is just the charge of a proton, so 1.6 times 10 to the power of minus 19. The velocity we've just worked out is 5.3 times 10 to the power of 5. B is 630 microtesla again, and sine 90, which is 1. And if we substitute that into our calculators, we should get 5.34 times 10 to the power of minus 17 newtons. Finally, part C, we're working out the acceleration of the proton. There's two ways to do this. We might as well do both. So first, since it's circular motion, we can use A equals v squared on r. We've got the velocity from before, that's just 5.3 times 10 to the power of 5 meters per second. That's all squared, divided by the radius of the circular path, which was 8.78. And putting that into our calculators, we get 3.2 times 10 to the power of 10 meters per second squared. Another way we could do this is just using Newton's second law. So A equals F on m. We just calculated the force in the previous question at 5.34 times 10 to the power of minus 17. All over the mass, we're told the mass of the proton is 1.67 times 10 to the power of minus 27. And again, substituting that to our calculator, we get the same value, 3.2 times 10 to the power of 10 meters per second squared. Either of those ways are fine. They both give you the same answer, as it should. That was a fairly straightforward question. Nothing too tricky about that, just some simple rearranging and substituting. And that's it.